Okay, just a reminder, it's been a while since I mentioned it to you. My name is Ron Bannon. If you need to reach out to me, particularly if you see an error in the document and you'd like to report the error, I would love to hear from you. Or if you have another concern related to making the document better, I'd love to hear from you. What I'm going to do now is I want to do this problem over here, and they want me to approximate the fourth root of 79. And granted, use a calculator. I say if you want to approximate that. But what we're trying to do is appreciate the binomial theorem here. So let's go to the generalized binomial theorem. Let's go to the whiteboard. And where's my whiteboard? Right over here. And I'll write it down for you. So I want the fourth root of 79. And I'm going to sandwich it between two perfect fourth powers. So I'm going to say between 81, and this one's going to be the fourth root. Well, let's see, 81's 3 to the fourth power. So what's 2 to the fourth power? 16. All right, and there's a point to this, that I do know the number, the fourth root of 79, just kind of looking at it, it's certainly closer to the 81. So what is going to be? It's going to be 2 point, and again, just think about it. I hope you realize it's going to be much closer to 3. So I'm going to say maybe like 2.9. And again, just kind of looking at it, it's certainly closer to this guy than it is the other one. But I still want to write it down. I still want to write this down. So the fourth root of 79 could be written as the fourth root of 81 minus 2. Or you could write it down as the fourth root of 16 plus, well, let's see, that's going to be 63, right? All right, so what I'm going to do is I'm going to factor out on this first guy 81. And you get 1 minus 2 over 81. Now, if you do this over, by the way, it's still going to equal the fourth root of 79. That's a given. Fourth root 16 factors out, and you get 1 plus 63 sixteenths. I'm going to claim this is bad news. This will not converge, all right? Now, by the way, it's equal. I'm not saying it's not equal, but if you use the generalized binomial theorem in this guy over here, is 63 sixteenths is greater than 1. It's just not going to work, right? The generalized binomial theorem only works when this number here is a proper fraction. And 63 sixteenths, it's larger than 1. It's not a proper fraction. So I must use this one over here. So let's write this down. The fourth root of 79 is going to be equal to, well, the fourth root of 81 is 3, and then the binomial theorem for the fourth root, by the way. And that should be written down and available. I'm not going to go through that again. We've done that many, many times before. So we're going to get 1 plus 1/4 minus 2 over 81. The first two terms are always really easy to write down. It's the ones that follow that are a killer, right? So minus 3 over 32 minus 2 over 81 squared plus 7 over 128. And you can expand this as long as you want, all right? There's a point to it, though. We don't want to expand it too long. And that's going to be cubed. And then, you keep going and going and going. 77 over 2048. No, I'm not memorizing these things. I have those expansions written down for you. And they're in your notes, by the way. They're easy to derive. I shouldn't say easy, they're derivable. And that's to the fourth power. And this goes on forever and ever and ever. All right? So what I'd like you to do on your own is, on your calculator, approximate the fourth root of 79. And it's going to be approximately something, it's going to be, I'm going to say approximately 2.98. All right? Now, your calculator will give you much more digits than that. Here's the deal, though. Your calculator can go out like 15 or more digits. What we'd like you to do is this computation. And I really mean that. Do the computation. And you're going to see how remarkable they are, how close they are. You also may want to try this and see why it doesn't work. It's not going to give you that, all right? Just not going to happen, all right? So I think we're good to go. I think, although I'm not doing the computing for you, use a calculator. Imagine in Wells's time, I guess in Wells's time, they were much bigger on arithmetic, but I guess as a grader in Wells's time, what they'd be looking for, were they capable of writing this down? And were they capable of writing this down? And then I guess the grader would have to start to determine, was the student able to do the computation to a level of accuracy that they wanted? All right? Thank you.